Hey guys, Miss Kulkarni here. In this video, let's talk about stoichiometry basics, and we'll also discuss mole ratio and how to use mole ratio in simple calculations. But before that, let's find out what is molar mass. Molar mass, which we write as mm, is nothing but the mass of 1 mole of substance. It could be any substance, and if it's an element, we find it directly from the periodic table. And if it's a compound, we need to make sure we add up the masses and get the molar mass for that compound. So, molar mass is kind of 3 types. Well, let me tell you, it's the same molar mass, but depending upon what we use for, we just classify it differently. So if we are finding a molar mass for the element, which we find in periodic table, that we refer to as atomic mass. For molecules, which we usually refer to when we talk about covalent compounds, the same thing, but we call now the molar mass as molecular mass. And if it's an ionic compound, then we call it as formula mass. Now, how about rounding the molar mass? Normally, we round up the molar mass to 100th place. And what is the unit for molar mass? Either we can use AMU, which is atomic mass unit, or we can also say grams per mole as the unit for molar mass. Now let's talk about conversion factors. So 1 mole, if we need to convert to grams, we are always going to go back and use the molar mass. If you want to convert 1 mole to liters for an ideal gas, remember, only if it is an ideal gas and at STP, which is standard temperature and pressure, then 1 mole will be equal to 22.4 liters. If you want to convert moles to the atoms or for particles, then we use Avogadro's number, not the avocado, but Avogadro's number, which is 6.022 10 to the 23. Atoms and molecules, they both are actually nothing but particles. So for both particles, we use same conversion factor, and that is the Avogadro's number. So I'm going to put down exactly same thing for all of these 3 things. Okay, that's going from moles to particles. What is mole ratio? Mole ratio is very important conversion factor. And how do you find out? It is the mole of one substance and mole of the other substance, and we take the ratio. So what do we need to have? We need to have for that purpose a balanced reaction, and we use the coefficients from a balanced reaction. Remember, if the reaction is not balanced, it is not going to work well. Okay, let's actually do work on some small problems. So in this one here, we have to find out all possible ratios. Let me first circle the coefficients. So for hydrogen, 2 is the coefficient. For oxygen, nothing is given. That means it is 1 as a coefficient. And for H2O, that's 2. So if I want to get the ratio of moles of H2 to moles of O2, what's the ratio? I just take the coefficient for hydrogen, which is 2, and divide that by coefficient for oxygen, that is 1. What about if I want to get moles of oxygen to moles of H2O? I get the ratio, which is going to be 1 for oxygen and 2 for water. How about if I want to get the ratio of H2 to H2O? You can write ratio like this also. So H2 is 2 as a coefficient, H2O is 2. Or I can write same thing as 2 divided by 2. So basically, if I know the coefficients, I can just use that as finding the mole ratio. And now we are going to find out actually conversion factor from one compound or element to the other one. So we are going to have 14.6 moles of oxygen gas. And then we need to find out if there is excess hydrogen, how many moles of water could be. So what do we need? We need the mole ratio for oxygen and water. You can do this in stoichiometry by writing the whole dimensional analysis, or you can just take the mole ratio. And I'm going to have simple mole ratio here. So let's write down, I need to get moles of oxygen to moles of H2. And my ratio is going to be O2 has 1 as the coefficient, so it's 1, and H2O got 2, so 1 divided by 2. Well, if I take same ratio and I use the values, I have 14.6 moles of oxygen, so I'm going to put here 14.6. And for 14.6, I need to find out how many moles of water I got, so that's the unknown. So this is my equation, and I'm going to solve that. The easiest way, is just to cross multiply. So if I do 1 times x is equal to 2 times 14.6, I believe we end up getting that as 29.2 moles of water. Was that simple? Let's do one more problem. So over here, we're going to do same reaction, but now the ratio is for hydrogen gas to oxygen gas. Again, let me write down the coefficient 1 here. So I am going to use these two substances. Let's write down the ratio, moles of H2 to moles of O2. What's the ratio? Moles of H2 is 2 and O2, oxygen, the coefficient is 1. Let's put that equal to, how many moles I got for hydrogen gas here? 6.80. And I need to find out how many moles of O2 are there. So let's put that as X. Simplify that. You got 2 times X is equal to 1 times 6.80. So X will be 6.80 divided by 2, and that should come 3.40. So many moles of oxygen. So did you realize by just having a balanced reaction and taking mole ratio, you can make easy convergence and find out the other moles. Hope you guys enjoyed the video. I'll see you again in next video. Until then, bye bye.